How does the web work? You use it every day. I mean, you're watching me right now in your web browser, presumably, but what is really going on behind the scenes? What do terms like backend, frontend have to do with one another? Where does Fast API fit in? Where does JavaScript fit in? These sorts of questions came up when I was teaching a class in Fast API just a few days ago, and I thought it might be useful for me to take a detour from my usual topics of Python and Pandas just to give you a broad understanding of how web technology works at a very simple level. So you can understand what some of these terms are. You can understand what web development is. You can understand why people talk about being front-end or back-end web developers and all sorts of other stuff. And I'm going to do it using some diagrams here that I'm going to create in real time in Keynote. I know it's a presentation program, but who cares? I'm going to use it for this. And I want to start off by not talking about the web. I want to start off by talking about email. That if we have two computers connected to one another, computer one and, very cleverly named, computer two. And we want people on computer one and computer two to be able to send email to one another. Well, it's pretty simple, right? We'll just connect them on a network. And then whenever someone on computer one wants to send mail to computer two, they'll do that. Computer two will be listening all the time and waiting for such a message. And similarly, if someone on computer two wants to email back to computer one is also going to be listening all the time and waiting to receive messages. This actually can work. This is what we call a peer-to-peer network. Two computers talking to one another directly. The only problem is that it doesn't scale. What happens if we have computer 3, computer 4, computer 10? Then every single computer will need a connection to every single other computer. That gets really complex really fast. And besides, the mail receiving program, what we call a server that's always listening and waiting to get information, that is a totally separate set of responsibilities from the email sending program. So what people did over the years is they said, you know what, let's change this. I'm going to have computer one, I'm going to have computer two, but they are not going to talk directly to one another. Instead, I'm going to put a computer in the middle, and I'm going to call that a server. And in this case, it's an email server. And basically, what's going to happen is computer one is going to send mail to the server, and the server will then be available for us to download our mail to our computers. Now, it gets more complicated than this because you have multiple servers. So a server can also talk to another server. But let's pretend we're inside of one organization here. So if someone on computer one wants to send mail to computer two, they send it to the server. And then computer two says, hey, server, do you have any email for me? And then it retrieves it. This distinction, this division between two different responsibilities in software has been around for a very long time. It's been around in email for a long time. It's been around in databases for a long time. And when the web was created, it was modeled similarly. And what we call our email program on our computer is actually known in this lingo as a client. This is known as client-server architecture, where you have sort of lightweight programs running on individual computers. Those are known as clients. And then you have a heavier weight program that's always listening on the network, known as a server. So in email, it seems kind of obvious. You have the email program on your computer, and you're talking to an email server in the sky, in the cloud, I guess we would say nowadays. And it can, again, either then talk to other email clients or can send the message along to other email servers. So if I send a message from my computer to someone at Gmail, so it goes from my computer, my client, to my server, from my server to the Gmail server, from the Gmail server to that person's client where they read it. And this happens all the time, billions and billions of times a day on email. So how does the web work? Well, it similarly uses clients and servers. And it started off super, super simple. Basically, the server is where information is stored, and the client is the one requesting it. And so basically what happens is if the client, like what happens when you make a request? What happens when you go into your browser and you enter a URL? So when you enter a URL, your browser, a web client, sends a request to a server. Well, what kind of request does it send? And believe it or not, it's actually sent in text, at least in the easiest to understand version of this. And it says get, and then it gives you the document. So if I say here, if I enter into my browser, I want something, something, something.com/ABCD. The client then connects to the server and says, hey, server, do you have ABCD? So we'll say /ABCD. And the server then has that document and returns it. So the client sends a request to the server. It says, give me document ABCD. The server says, here is document ABCD, or it gives you an error message saying, I don't have document ABCD. That was the original way that the web was designed to work. It was a document retrieval service. You say what document you want, the server says, here it is, or says, I don't have it. Does that really describe the web today? Not exactly. Things have gotten more complicated at every possible level of what I just described. And the biggest thing that changed is that the servers lie to us. So if the client says, give me ABCD, what if ABCD doesn't really exist? But the server says it exists, runs a program, and the output from that program is sent back as ABCD. In other words, as far as the client is concerned, and by the way, in the world of the web, the client is known as what? That's right, it's the browser. So your browser says, give me ABCD, and the server says, hold on a second, let me give you ABCD, runs a program, and the output from that program, which is created for you just in time, just for your purposes, is sent back. And your browser, your client, is totally satisfied. Hey, I got the document back that I requested. Is there really an actual file representing that document on the server? Absolutely, positively not. But this lie is really useful because it means that every time I go to Amazon or every time I go to any other website, my browser believes it got a document, the server has constructed the document on the fly, and everyone is happy. So that is the basic way that the web works. And this works in two, well, basically, we have then the browser sending what's known as a request to the server, and the server sends a response back to the browser. And this happens again and again and again. And of course, there can be many browsers connecting to the same server again and again and again. There's nothing wrong with that. In fact, right, we want that. If we are running a website, the thing that we want most of all is lots of people to connect to our servers. And at a certain point, the server will sort of give out because it can only handle so many connections at once. That said, a modern server can handle many connections at once. You really don't need to worry about it falling over from overuse unless you have an extraordinarily popular website. So this is the basic model of how things work. The browser sends a request, the server sends a response, and the response is created on the fly. Okay, so where do things get more complicated? And the answer is everywhere. First of all, what is the response? So the response traditionally was in HTML, the hypertext markup language. And you might have seen it before with angle brackets and things like P and A and span and div. And HTML is still used for websites that we people look at. But you can actually transmit any sort of document. You can also transmit, right? You can also send images, so PNG or JPEG or PDF, or you can even send other sorts of computer readable values, computer readable documents that are not really meant for people. For example, JSON. This is known as JavaScript Object Notation. And we're going to get back to this in just a little bit. But basically, a server can return all sorts of different kinds of data. And as long as your browser knows how to display it, or knows that it doesn't know how to display it and it's going to save it to disk, all is good. And that, by the way, is sometimes why you'll be prompted to save a file, because your browser is like, I don't know how to show this, but I do know how to save it. Would you like me to do that? One important thing to keep track of or to understand is that each request asks for one document and each response returns one document. What does that mean? It means that if I go to a web page that is just text or just HTML, great. What if I go to a web page that has HTML and 5 images? Actually, what that means is my client needs to make 6 separate requests, 1 for the HTML and 5 more for each of the documents. And that's because each request is done independently. Granted, modern web technology has changed this a bit so that things can be bundled together a little more easily. But in general, when a browser says, give me something, it gets that something and then hangs up. Give me something, gets that something hangs up, hangs up. And so if you have a whole lot of images on a web page, that's going to be a whole lot of requests that are going to be made to the server. Well, wait a second. We know that things are displayed nicely on our screen in a browser nowadays. How's that done? That's done using something known as CSS, Cascading Style Sheets. And I am not a designer of any worth, but I do know a little bit about CSS, and CSS is a separate standard that works in concert with HTML, and the HTML is then the text and the sort of description of what is a paragraph, what is a list, what is a headline, and the CSS says how should it be displayed. Should it be displayed in pink or in green or in bold or big or to the left or to the right or in a table, all sorts of different things. All right. So that explains then the HTML that's coming back, and the CSS that's coming back. There's one more thing that can come back, which is JavaScript, and that is code that runs on your browser. In other words, when I make a request to a server, I might get back HTML, I might get back CSS, and I might get back JavaScript, which is code that the server is providing and the client is running. Now, if that sounds a little scary to you, you are right to be worried. Does this mean that I connect to a web server and it can run any code it wants on my computer, on my browser? The answer is yes, sort of. For this reason, browsers are really, really worried. They're a little paranoid, and rightly so, about the security. And so they won't let programs talk to your disk. They won't let programs do all sorts of different things if they were downloaded from the web in JavaScript. And this actually is a challenge for many programmers, because they're like, oh, I want to do X and Y and Z. And the answer is no, you can't. You are what's known as sandboxed. You are stuck inside of the browser and you can't break out. I mean, imagine if you were to go to a website and you were just see its web page and it were to surreptitiously have your browser start spamming people with email. That would be pretty bad, right? Yes, it would. And so your browser is built with all sorts of security safeguards to make sure that that shouldn't happen. I'm sure there are all sorts of security people who will tell me, oh yes, well actually it's possible in such and such ways, but generally speaking, it should not be happening. So when you hear about backend programming, what people are talking about is writing programs that run on the server. They are the programs that create these documents dynamically. They are talking about the programs that create sometimes the CSS and the JavaScript dynamically. They figure out what images to show you. They figure out what prices to put on products. That is back-end development. By contrast, front-end development is basically CSS and JavaScript. Yes, it comes from the server, but it is displayed in the browser and it runs in the browser. And so you're writing programs that are stored on the server, but that will actually be run in a totally different environment in the browser. A few more things to explain here. First of all, what if this back-end program wants to do something really sophisticated? Like, what if it wants to store information about the user's preferences? Like, we want to know what you've clicked on. We want to know what products you've looked at. We want to know who you are so that we can show you products that you're more likely to buy. Well, the server then can have a database inside of it, right? And that's very, very common, or alongside it. Actually, in many cases, believe it or not, the server will be a client to a database server. And so then basically we will have the web server connect to a database server and store and retrieve information about you from there. Okay, and that's super, super common as well. Let's just make these arrows go in the right way, right? And so what kind of database? You have lots of different kinds of databases out there. You have SQL relational databases, you have NoSQL databases, you have a whole variety of different ones. And so back-end programming typically means, oh yeah, I'm writing programs that are going to run on the server, but they're going to consult with a database to store and retrieve information. So typically, people who are doing back-end programming need to know about web technologies. Yes, they do. But they're usually writing their programs in a language that the user will never see. You have no idea what programming language is being used in the server if you're just on your browser. And you have no idea what database is being used. That is all masked from you because all you're getting is a response. So how can you write programs on the server? That's where programmers love to have lots of debates, right? So back-end programming can be done in any language. right? And so you can use Python, or you can use Java, you can use JavaScript, or you can use Golang, or all sorts of other things. Now, could you write from scratch in Python or in Java or in JavaScript or whatever you want to use? Could you write your own libraries, right? Your own functionality that knows how to talk to the database and knows how to put together HTML, knows how to do all this stuff? Yes, you could. But why reinvent the wheel? Lots of other people are doing the same thing. And so usually you'll use a back-end framework to write your code. And so in Python, we have Flask, we have Django, we have Fast API, right? Those are all Python. In JavaScript, we have Node.js, and it just goes on and on. And whatever framework you use is keyed to a language, and that will indicate, basically, that will determine or dictate how you talk to the database, how you deal with users, how you deal with security, how you deal with administration, how you deal with logging, all sorts of things that backend programmers need to deal with. Now, front-end programming, as I mentioned, is done in JavaScript, and there too, there are frameworks for front-end development. Now, because JavaScript is the only language that currently runs in all browsers all the time, you can basically say that all front-end development is done in JavaScript. But even there, we have frameworks, right? So the biggest one that people are using nowadays is called React, but you have lots and lots of other front-end frameworks as well. And here's the cool thing. Over the last few years, some people have been saying, well, it seems kind of unfair and silly that only JavaScript should run in the browser. What if we made it possible for any programming language to run in the browser? So you now have what's known as WASM, or WebAssembly. And this allows other programming languages to run in the browser as well, alongside and in conjunction with JavaScript. So can you now write front-end programs in Python? Yes, you can. It's still a little new, it's still experimental, but it is possible. And you can even use the JavaScript libraries that are also loaded in your Python program and talk to them that way. All right, one last piece of terminology I want to share with you before I finish this already longish video. If you live in Europe or a similar area of the world, every time you go to a website, it says, hey, do you want to accept cookies? What the heck are cookies? So part of the elegance, simplicity of the web is this request-response pair. You send a request from your client to the server sends a response back, done. They then disconnect. Again, nowadays, it's more modern than that, it's more sophisticated than that, but as a general rule, that's the way it works. So every time the client connects, it needs to say who the user is, right? Because every request response pair is done in a vacuum. It doesn't keep any context from one request to another. This is a little bit of a problem. If you are logged into, how can you log into your bank, right? You send a request to your bank's website. It sends a response, here's the home page. You send a request saying, hey, I'm, my username, my password. It says, that's great. Response, hangs up. So now how are you supposed to get your balance? Because the next request doesn't remember what was done in the previous one. So basically, cookies are the following. When the server sends a response, it says, the next time you contact me, remind me that x equals 5. Right? So the client sends a request to the server sends the response back, and as part of its headers, metadata, data outside of the usual or part of the response but outside of the content, it says, next time you contact me, remind that x is 5. And the client stores this information, stores this variable name and value in what we call a cookie in the browser. The next time it sends a request, it's like, hey, would you give me ABCD? Oh, and by the way, x is 5. The server uses this number and this data to look up the user in the database and then can send a personalized response. This allows the web to work in its modern way. It basically says, I want to remain logged in even though the web, the underlying technology, HTTP, doesn't allow for logins to happen. So cookies are fundamental to how the web works, and I find it a little amusing / annoying that people are so scared of cookies and that you now need to say, yes, 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 I want cookies all the time, when they're not doing anything nefarious on your computer. All they're doing, in theory, right, unless they're security breaches, all they're doing is storing a name and a value that will be repeated back to the server in the future. Now, all this is great, and all this is true. Again, simplified a bit, but it's true. But what about phones, mobile phones. Do they have a role to play in this? And the answer is, of course they do. Sure, you have a browser on your phone and you can use it to connect to web servers. But there is a newer, different way to think about this as well. What if the client isn't a browser, but a program? And what if it doesn't request text or images, but JSON data? Now, JSON data, again, I mentioned earlier, it's called JavaScript object notation because it comes from JavaScript. You don't need to know JavaScript to know about JSON, but it basically is, right? This means data that is computer readable in many languages. What does that mean? It means then that the client is going to send a request to the server and say, hey, give me the latest stock information for such and such a company, or give me the weather forecast for such and such a city. The server will send it back, but not as text that can be readable for the user, rather as data in this JSON format that is usable for a program. It's then up to the program to display things. So what if instead of the client being a browser, it's a mobile app? Right? Now the mobile app has gotten data back from a server and it's able to display it to you however it wants. So my phone has dozens of applications that are constantly running, let's say for weather, let's say for fitness, let's say for location. And each of these apps is a client that is talking to some server out there in the world, getting a response back and using that to update its information to display things for me and so forth. And so the idea of an API, the idea that a program is talking to another program and that it is using JSON for this communication has become increasingly widespread. You could even argue, I haven't really checked any numbers on this, but it seems likely to me that there are many more computer users of the web exchanging API information in JSON than there are human users going to actual websites nowadays, because every app is on your mobile phone is a JSON API client talking to some server, getting information, and for that matter, updating the server as well. All right, this was, I realized, a lot to absorb, but I hope that it helped to put a lot of this terminology into context, help you to understand how the web works, the magic that's going on behind the scenes every time you enter a URL or click on a link in your browser. I would love to hear what other questions you have, where I was not clear here, where I could expand on this, and what else you want to know. Thanks so much for watching. I look forward to your comments. Don't forget to like and subscribe, and I'll be back real soon with lots more about technology in general, but also about Python and pandas and everything in between. Thanks again, and see you soon.